here's the experiment. Now this is actually diffusion, but diffusion goes by Graham's law as well. So we have a 40-centimeter tube, glass tube, with graduations on it, and there's a cotton plug in each end, and simultaneously ammonia water and dilute HCl are injected into the cotton plug. Okay? Now, once the ammonia vapors get to the hydrogen chloride vapors, they're going to react to form this white solid ammonium chloride. And we will see that somewhere in the tube once the two gases meet one another. Okay? So if the gases start at the same time, where will they meet? By Graham's law, the rate of traveling down the tube of ammonia divided by the rate of HCl is equal to the square root of the molar mass of HCl over the square root of the molar mass of ammonia. There's your inverse relationship. Now, of course, in this case, we don't actually have rate data, but rate is equal to distance over time, right? How far it traveled in a given time period, let's say a minute. All right, so what we can do is we can substitute distance of ammonia travel over the time that it traveled divided by the distance HCl traveled over the time that it traveled. And this is what we would have here. The rate ratio is equal to the distance over the time for ammonia divided by the distance over the time for HCl. And those would, of course, be equal to the square root of the ratio of the molar masses. Now, the one thing we know here is the time is going to be the same for each gas because they start at the same time, right? So if you look at this expression, time for ammonia cancels out with time for HCl. Right? So what we have then is a relationship which says the distance of ammonia over the distance of HCl is given by the square root 36.5 grams per mole for HCl and 17 grams per mole for ammonia. If you plug in these numbers and take the square root, you get a relationship that the ratio of the distance of ammonia over the distance of HCl is 1.47. Ammonia is a lighter molecule. It goes faster, goes at a higher rate. But we've still got two unknowns in one equation. We need a second equation. A little algebra here. Stand back. Don't get anybody on you. The distance from ammonia that ammonia travels plus the distance that HCl travels is equal to 40. Right? If they start each end and they meet in the middle, the total distance traveled is 40. So it just different equation here, same two unknowns. And what I'm going to do is I'm going to substitute for the distance of ammonia here, 1.47 times the distance of HCl. Okay, so I'm going to say 1.47 distance HCl, which is equal to the distance for ammonia, plus the distance for HCl, is equal to 40. So a little bit of algebraic prestidigitation. We're down to one variable here. So the distance of HCl is equal to 40 divided by the sum of 1.47 and 1, which would be 2.47. So that will end up being 16.2 centimeters. So ammonia will, HCl will travel from here down to 16.2 centimeters down this direction. Well, the tube is graduated in the other way, so let's just take 40.0 centimeters minus 16.2 centimeters, and we get 23.8 centimeters. And that's the ammonia rate. So somewhere in here, around 23.8 or 24, they're going to meet.